Today is probability with or without replacement. Most of these questions will be without replacement, meaning you don't put it back into the tub that you pulled it out of. So a bag contains marbles of the same size. That's pretty important to keep the probability fair. Like all those highlighters were the same size, same shape. You know, like if the marbles were different sizes or anything like that, you have a more likely chance of picking a bigger one out than a smaller one. So 4 green, 6 blue, 2 red. We need to figure out how many total highlighters there are, so we add those bad boys up. 4 plus 6 is 10, plus 2 more, isn't there? 12 total. You would probably be advised to write a total down. They say find the probability of a blue, then a green without replacement. We'll keep it simple for ourselves, right? So let's do this. If we do a little want over total, first of all, how do you feel that to start with, there are 12 total marbles in the bag to start with, right? How many of them are blue? 6. Boom. Who cares about reducing that? We're going to leave it 6 over 12. That sound okay? So we pull the marble out. Then on the second time, they ask us, you know, to do it again. My question is, since we did not replace it, what is the total number of marbles in the bag at this point? 11. 1 less. Are you with me on that? How many of them are what they asked them to be green? How many of them are green? Well, we didn't affect those, so isn't there 4 of those? Are you cool with that? So all we do is multiply those together. Grab your calculator, and especially if you have one in mind, the easy way to do it is to put them in parentheses. So if I do parentheses 6 divided by 12 times parentheses 4 divided by 11. Cool how I'm punching that in? Like, I could care less about reducing them because many of the questions on homework will ask you to have decimals instead of a fraction. So we're going to do this. They'll say round to so many decimal places. Most of them will be 4 decimal places. So to round to the 4th decimal place, I got to look to the 5th guy. 1, 2, 3, 4, 5. You see that 5th guy is a 1, so I will not round that dude up. So 0.1818. What we're going to do on this is put both the decimal and the fraction just so we can practice getting the fraction back. So if you have one of my calculators, hit this key sequence. It's called Math Enter Enter. Can you see this button right here that says Math on it right there? Hit the Math button, and then you just hit Enter twice, and it will change it to a fraction of 2/11. Because sometimes they ask you for the decimal, sometimes they ask you for the fraction. On your phone calculators, if you're just using the app for calculator, I don't know how to do that. If you have a graphing calculator that's a little different than mine, I can figure out how to do that if you're not sure how to do it. So let's do that again. Find the probability of a green, and then a green, and then a red. So first, it all started over. So we got all 12 marbles back in there. How many greens are there? 4. Then times. The thing that changes, because we're not replacing, is the denominator. Now there will only be 11 marbles in the bag, and they wanted another green one. So since we supposedly pulled the green one out the first time, there are no longer 4 of those. Would you believe that there are only 3 green ones? Cool. And then, would you believe we've pulled another marble out of the bag, so there are only 10 there this time. And then they say a red one. Well, all the red ones would still be in there. So we'll go to the calculator and use parentheses for each one of those fractions. 4 divided by 12, parentheses, times 3 divided by 11, parentheses, times 2 divided by 10. And then we'll round that to 4 decimal places. It almost looks like the same number as before, but it's not quite. There's a 0 in there. That is very unlikely to happen. So 1, 2, 3, 4. To the 5th spot is what we'll do. That is an 8, so we got to round that up to a 2 right there. So 0.0182 is what that would be. 0.0182. Then I'm going to hit Math Enter Enter on it to change it to a fraction just in case. So Math Enter Enter. And that's 1 out of 55 shot, which is not likely to happen. This dude right here as a decimal is like the probability of it. To change it to a percent, which they don't ask you to, it would be you've got like a 1.8% chance of actually doing that. Not likely to happen. To pull a green out, then a green out, then a red one, probably not going to happen. It is possible. You had like almost a 2% chance. So find the probability of a green, then a blue, then a red. Let's do that. Green was... It all started over, 4 out of 12. A blue, there were 6 of them in there, but there's only 11 marbles now. And then a red, there are 2 reds out of 10. So we'd multiply all those together. 4 divided by 12 times 6 divided by 11 times 2 divided by 10. The denominator changes when we don't do replacement. If you don't put the marbles back in or whatever device you're pulling out. So that's 0.0364. And then if I hit math, enter, enter on it, it changes it to 2 out of 55 chance. Not very likely. How do you feel about those guys? Are we okay with that? Those are usually pretty good. It's just like, you don't have to know anything about marbles. It's just like, how many are there and how many colors are there, right? So the cards is what kind of gets us, but we'll get to that on number 3. This one, weird question. A drawer contains some batteries in it, but they're all the same size. 8 of the batteries are good batteries. 3 of them are dead. You need 2 batteries for a remote. You just reach into the drawer and grab 2. Find the probability that they are both good batteries. How do you feel about how many total batteries were in there? There was 8 good and 3 bad. Never a good battery. So 8 good and 3 dead. So how many total batteries? 11 total. You want both of them to be good. So the first one, 8 out of 11, because there's 8 goods out of 11 total batteries. Then the second one, how many total batteries would be in there after you drew the first one out? There would only be 10. And how many good batteries would there be? Because you supposedly drew a good battery in that first one. So how many good batteries would there be? 7. 1 less, right? So we just multiply those together. Bless you. 8 divided by 11, right? Times 7 divided by 10. And I think this is a question on homework. You don't quote me on it, but I think they want this one as a fraction, you know? So like having the decimal, we'll put both. We'll go 0.5091, 0.5091, but they probably want the fraction, so just math, enter, enter that bad boy. So 28 out of 55 shot. About a 50% chance. You know, we saw that right here, a little over 50%. Feel okay so far with the replacement stuff? You know, you just got to watch. Then the deck of cards, that's where it's just like, man, I don't know anything about cards, right? So I don't know how many there are or anything. I hope we're getting that down that there are 52 cards possible in a standard deck. And it says if we draw 2 cards without replacement, what is the chances that the first card is an ace and the second card is a 5? So let's go with the first card. Remember, there were 52 possible. How many aces are there? How many? There are 4 aces. I don't need to reduce that, you know, because it does reduce to like 1 out of 13, but I'm not worried about reducing it. So the first card was an ace. There's a 4 out of 52 chance of doing that. Second card, we did not replace it, so guess how many cards are in the deck now? Just 51. They ask the second card being a 5. Well, if we pulled an ace the first time, aren't all the 5s still available? Guess how many 5s there are? There are 4 of them. So those are our 2 fractions, right? And I will have this deck of cards and any deck of cards question on your quizzes and stuff so you can see them, right? You know, because some people are good with cards and some people are not. So 4 out of 52 times 4 out of 51. And that is very unlikely to happen, 0.0060. Which, if we math enter that, is a 4 out of 663 chance. 663. Is that right? Yeah, that's right. Cool. Not even a 1% chance of that like happening, you know. It's like a 0.6% chance. Cool. Here's a good one. Suppose this happened. Suppose I got this deck of cards right here. I pulled out 3 cards. The first card I pulled out was the King of Spades. If you are not sure what these symbols mean, just ask me, and I'd be happy to tell you. It's out of the suits, the hearts, the clubs, the diamonds, and the spades. So first card I pulled out, King of Spades. Then I pulled out another card, the 9 of Hearts. Then I pulled out a third card, the King of Spades. Can you decide if, when I did that, if I put the cards back in or I kept them out? Or should I say if I replaced them or did not replace them? King of Spades is what I showed you. Then I showed you the 9 of Hearts. Then I showed you the King of Spades. Did I use replacements? Yes is the answer. How do you know that I replaced the cards before I drew another one? Yeah, would you believe the King of Spades showed up 2 different times, right? And there's only one of them in the deck, right? So the answer to that is yes, because we picked the King of Spades twice. I don't care if you write that down or don't write that down. That's up to you. But if you pick the same card more than once, that means you had to have put it back in the deck. Are you with me on that? There's only one of each of these. In a normal deck of cards, get to a, like, pinochle deck, that's a different situation. You know? If any of your parents, grandparents, great-grandparents play that game. So because we picked the same card twice. And then the last thing has some very fancy, like, symbolism. I looked through the homework, and they don't use the symbolism on there. They put it in English, which is good for us, right? So, but the symbolism is this. It's like this up and down thing, which means, like, given. P stands for probability, and then the up and down thing means given. So let's dive into what it's all about and then go back to the symbolism. Using the chart at the right, it's about like test scores versus gender. It says find the probability that of getting a B given the student is a male. So the given means, okay, that's all we care about. All we care about is the student is the male. So like, let me make it easier for you. What if I said I'm going to pull a name out of the hat, all your names are in there, and the winner that I pull out gets $1,000, right, from me. But given, only girls' names are in there. Right? Would you believe that no boys have a shot at it then in that case because there was a given stipulation, right? So they say, what is the probability of getting a B given that the student is a male? Are you with me on that? Would you believe we don't care about the females in this particular question then, right? So I like to do this. It kind of helps me out. I'm going to do want over total, and then here's what I want, like here's who the total is. The total is nothing but males. Are you with me on that? The total has got to be males only. That's the given stipulation. Can we look to the chart and see how many total males there are? There, you see here's males, and then going across, there's the total right there. So there are only 21 males total in that particular class. What do they want us to see is the chances that those people got a B. So it has to be a male that got a B as well. Are you with me on where that I circled that? I only looked in this column because these are all the males, right? And 2 of them got a B, right? 2 of them got a B. So I wanted a B out of all the males. So we can punch that in to see what that is as a decimal also. It's just 2 out of 21. So 0.0952. Which as a fraction is, if we math enter it, it's probably going to be 2 out of 21. So it didn't even like reduce. Just read the question to see if they want it as a fraction or as a decimal. If they don't tell you, I think it would accept either one, you know. Cool. So last one here, using the chart, it says find the probability of getting a female given the student got an A, so want over total. If you want to make a note for yourself, the given is on the bottom. Like whatever they say is a given, that's on the bottom. So on the bottom they say given they got an A, I need all the A's on the bottom. So erasing all my junk from this chart, I need to know the total number of A's. What do you feel that should be? That's 15. Here's the A column. All right, we're going up and down now, and are we down where there are 15 total A's in that classroom? I know it's backwards from last time, right? So we got to read carefully. So they say, what's the chances that that person is a female? So I want a female up top. But they had to have gotten an A first. Like, that's the only people that were put in the bucket. Everybody who got an A is in the bucket. There's 15 names in there. How many of them are female names? 9. Right? So 9 out of 15, which we will punch in, which is 0.6. So there's like a 60% chance of that. And then if you hit math enter, that will reduce that fraction to 3/5 if they wanted it as a fraction. Cool? That is lesson 6.3.